The plans came rolled inside the box. Not folded, not stapled, not reduced to a numbered diagram on a single sheet, but rolled. The way an architect rolls something important. The way engineers carried drawings before the world went digital. You unrolled them on the table and held the corners down. And what you were looking at was the aircraft in its entirety. Every rib, every spar, every stringer, every former, drawn at full scale on paper that smelled of ink and technical intent. The aircraft did not yet exist in the world. It existed only in the drawing, waiting for the person who had just unrolled it to bring it from the paper into the air. The balsa in the box was die cut, or sometimes score cut, and it was good balsa. The Zaic family had understood from the beginning that the material was the foundation of everything, that an aircraft built from poor wood would not fly the way the designer intended regardless of how carefully it was assembled. The sheets were thin, surprisingly light for their size, and each part was connected to its neighbors by the small bridges of wood that the cutting process had left between them. You pressed the parts out carefully, because the balsa would split along its grain if you forced the separation, and a split part was a part that needed to be glued and dried and trimmed before it could be installed. You were already learning, then you sorted. Ribs in one pile, sorted by station number. Spars to the side. The small fuselage formers, each one a cross-section of the aircraft at a specific position along its length. The tail surfaces, which would be built last because they were simpler, but had to be built correctly because an incorrect tail surface was the kind of error that the air was enthusiastic about revealing at the worst possible moment. The instruction sheet was a separate document, a text printed on a smaller sheet, describing the construction sequence in the language of someone who had built the aircraft and knew where the difficulties were and wanted to prevent them. The building board was a flat piece of soft wood, usually pine, into which the T-pins would sink without damage, and from which they could be pulled without the kind of effort that disrupted what you were pinning. And you laid the plan over the building board, a sheet of wax paper over the plan so the wood wouldn't be glued to the drawing, and you began. The first rib, which was the root rib, the largest rib, the one that established the wing's geometry at its deepest point. Placed over its position on the plan, pinned, then the next rib and the next, each one smaller as the wing tapered toward the tip. Each one placed exactly where the plan showed it should be placed, verified against the drawing beneath the wax paper. If you remember laying a plan like that one across a building board late at night, if the smell of fresh balsa and rubber cement is something your memory still carries, take a moment to like this video and subscribe, not for the algorithm, but so stories like this one don't fade away in the way that the companies and the kits and the hobby shops that defined a generation of American builders have faded. The history of Jetco Models and the broader history of plan-based kit building deserves a record. The question that the Jetco story ultimately poses is simpler than it might appear. Did Jetco Models disappear because the market changed? Or because we stopped building things that required patience? The answer involves both, but the order matters, and the order is not what nostalgia tends to suggest. Frank Zaic was born in Slovenia in 1912 and arrived in New York City with his brother John in 1922. He was building model airplanes before he was 10 years old, and by the time Charles Lindbergh crossed the Atlantic in 1927, Zaic was already a serious student of the aerodynamic theory that most modelers of the era were absorbing empirically through the trial and error of building things that flew or didn't fly and trying to understand why. He was different from most of his contemporaries in that he went to the New York Public Library, and read what was available on aircraft theory, which in 1927 was not very much, but was more than most teenage modelers had access to. And he synthesized what he read into an understanding of why model sailplanes behaved the way they did. In 1933, Frank, John, and their sister Christine started a supply company for modelers in New York. The name was JASCO, Junior Aeronautical Supply Company, and it served the community of modelers who were scattered through the New York metropolitan area and who needed balsa and tissue and rubber and the other materials of the hobby at prices they could afford. JASCO was not initially a kit company. It was a material supply company, and its distinction was the quality of what it supplied. The balsa that came from JASCO was selected balsa, not the random assortment of grades that some suppliers offered, but consistent, properly dried, correctly cut material that would behave the way balsa needed to behave in the applications modelers were putting it to. The story of how JASCO acquired that balsa tells you something important about the organization's character. The wood arrived in the form of roughly dressed square timbers, approximately 10 inches square and 8 feet long, and had to be carried up 2 flights of stairs to the operations workspace. These were large pieces of wood, and you would expect them to be heavy. Balsa is not heavy. The timbers that the JASCO operation manhandled up those stairs could be managed by one person without unusual effort, because balsa's specific gravity is so low that even large pieces of it weigh less than you expect them to. The people who worked with JASCO's balsa described it as excellent. Not just light, but consistently excellent. The kind of wood that behaved predictably under the tools that modelers used on it, that sanded to the correct profile without the inconsistencies that lesser quality balsa introduced. This material quality was the foundation of JASCO's reputation, and later, Jetco's. The modeler, who had built from JASCO or Jetco kits, and then built from another manufacturer's kits, could feel the difference in the wood, the density, the grain, the way the razor blade moved through it, and the way the surface responded to the sanding block. One person who had bought modeling supplies from JASCO in the early years, before he was even out of high school, later recalled that he had learned early that any kit with the JASCO name would definitely fly if built correctly. This was not universal praise for all kit manufacturers. It was a specific testimonial to the specific standard that the Zaic family had established and maintained. Frank's intellectual contribution to the modeling world was the yearbook series he began publishing in the late 1930s. These were not product catalogs. They were technical documents, annual compilations of design theory and construction practice and competition results, organized by someone who understood the aerodynamics of free-flight models at a level that most practitioners of the era had not reached. The Zaic yearbooks became essential references for serious free-flight modelers throughout the country, and they built Frank's reputation as a theorist and designer whose understanding of slow-speed aerodynamics was genuinely exceptional. The Thermic sailplane series that Frank designed for JASCO demonstrated this understanding in physical form. Thermic sailplane was not merely a model that could catch a thermal. It was a design that had been organized from the beginning around the aerodynamic requirements of thermal soaring, low wing loading, correct dihedral for passive stability in the thermals that would toss the model unpredictably, airfoil selection that produced lift at the low speeds that a thermal-seeking flight profile required. These were not intuitive choices. They were the product of someone who had thought systematically about what the air was doing and what the aircraft needed to do in response to it. After the war, Frank's attention moved to the West Coast, where he worked as a draftsman for aerospace companies and continued publishing his yearbooks as a supplement to his income. The ownership of JASCO passed to John and Christine. Frank wanted to maintain the JASCO name for his continuing projects. So the kit company, now under John and Christine's direction, was renamed Jetco. This renaming marked the transition from one chapter to the next, from the pre-war and wartime era of free-flight gliders and rubber-powered models to the post-war era of powered kits, and eventually the early radio control applications that were becoming possible as the electronics miniaturized and the costs came down. The post-war world that Jetco entered was a world in genuine ferment about model aviation. The men who came back from the war had spent years in proximity to aircraft. Real aircraft, the aircraft of the most consequential air war in history, and the model aviation hobby was, for many of them, a way of maintaining a connection to the world of flight at a scale and cost that civilian life made possible. They built model aircraft, not as a childhood pastime, but as a serious adult pursuit, and they brought to it the mechanical competence that years of service had developed in people who had maintained and operated actual aircraft engines and control systems and structural components. And this was the community into which Frank Ehling arrived. Ehling had been publishing designs in Air Trails magazine, sometimes under his own name, sometimes under pseudonyms, and was known in the model aviation community as a capable designer with a particular facility for producing aircraft that were both buildable by average modelers and capable of performing well when correctly built. He had won the prestigious Mirror Meet in New York with his Phoenix model powered by a new Ardent engine provided by his friend Ray Ardent. The Phoenix was a pylon-powered design, a glow engine model organized around performance in the specific format of the competitive class, and its success at the Mirror Meet demonstrated that Ehling understood both the aerodynamics of performance models and the practical requirements of a design intended for production. John and Christine Zaic hired Ehling as a full-time designer and manager of the kit packaging operation. What followed was a period of considerable productivity. The Phoenix series, multiple variants of the successful pylon design, each one adapted for a different application or a different engine size, was Ehling's primary contribution to the Jetco catalog. The baby Phoenix became, in the assessment of people who flew it, a terrific flyer, the kind of design that worked off the drawing board, that flew as the designer intended without the elaborate trimming and adjustment that more theoretical designs sometimes required. The Nordic, which Ehling designed for the towline glider class, that was then a serious competitive category, was described by those who flew it as a superlative design, competitive, reliable, an aircraft that would fly well in the hands of a pilot who had built it carefully and trimmed it correctly. Jetco also introduced nylon as a covering material, an innovation that predated its widespread adoption in the hobby, and that demonstrated the company's willingness to look beyond the traditional tissue and dope construction method when a superior alternative was available. The nylon covering was more durable than tissue, more resistant to the moisture that could soften the dope and tissue combination, and it applied to the balsa framework in a way that produced a surface finish that many builders found superior to the traditional material. The transition to early radio control was a specific challenge that Jetco navigated by responding to what the DeBolt organization was doing. In response to the DeBolt Live Wire Trainer, one of the early single-channel RC models that made radio-controlled flying accessible to a broader population by reducing the complexity of the radio system to a single-axis control, Jetco released its own single-channel RC design. The model's significance in the company's history was in its introduction of the nylon covering that would later become standard. As an aircraft, it represented Jetco's engagement with the RC transition that was beginning to reshape the hobby's landscape. The building experience that a Jetco kit delivered was specific to the company's heritage and philosophy. Because Jetco grew out of a family tradition that had begun with Frank Zaic's rigorous approach to slow-speed aerodynamics. The kits that Ehling designed for the company carried the assumption that the builder's work mattered, that the dimensions on the plan were the correct dimensions, that the construction sequence in the instructions was the correct sequence, and that the aircraft the plan described would fly correctly if it was built correctly. This assumption placed a specific responsibility on the builder. To build correctly was not to build quickly. It was to build with the attention that the plan's precision demanded, to verify each rib's position against the plan before gluing, to check each wing panel for warp before joining the two panels at the center section, to confirm the alignment of the fin and stabilizer before the dope dried and made the position permanent. These were not difficult tasks. They were patient tasks, and the distinction between difficulty and patience is the distinction between a skill that can be developed and a disposition that has to be practiced. The sanding of the leading edge was the task that most clearly illustrated this distinction. The leading edge of a balsa model aircraft was typically a strip of slightly harder balsa, or a half-round strip, that had to be sanded to an elliptical profile, the rounded front of the wing's airfoil that determined how the wing interacted with the airflow at low speeds. Too sharp, and the leading edge would produce turbulence at low angles of attack, reducing the wing's lift efficiency too blunt, and the edge added drag without benefit. The correct profile was a specific shape shown on the plan as a cross-section through the wing at the leading edge station, and achieving it required removing material from the strip in a controlled way. Not just sanding, but sanding with a specific awareness of the shape you were working toward, checking frequently, feeling the edge under your fingers to understand where more material needed to come off. You develop the feel for this. The first time you sanded a leading edge, you did not know what the correct result felt like under your fingers, because you had not felt the correct result yet. By the third or fourth kit, you knew your hands had accumulated the reference that your eyes could not provide, the specific roundness that was neither too sharp nor too blunt, the smoothness that meant the surface was ready for covering, the slight spring back of correctly sanded balsa that distinguished it from balsa that had been oversanded to the point of weakness. This was knowledge in the hands, knowledge that words could not transmit and that the plan could only approximate. Covering with tissue was its own conversation between the builder and the material. The silk span, or the domestic tissue that the Jetco kit supplied, had to be cut to shape, applied to the balsa framework, dry, tacked at the edges with dilute dope, misted with water to tighten, and then sealed with successive coats of dope. Each coat of dope shrank the tissue further as it dried, tightening the surface against the ribs and spars beneath it, until the final result was a surface taut enough to ring when tapped with a fingertip. The dope smell was total and specific. Butyrate dope, which is a chemical compound that has no natural counterpart and whose odor is, for anyone who has spent evenings with it, inseparable from the memory of building. The tail surfaces required a different kind of patience, the patience of alignment. The horizontal stabilizer had to be square to the fuselage center line, and the vertical fin had to be square to the horizontal stabilizer. And both of these alignments had to be achieved and then locked in place with the dope that would hold them while the rest of the construction was completed. A tail that was out of alignment produced a model that flew in a consistent circle. not the gentle, thermal-seeking spiral of a correctly trimmed glider, but the aggressive ground loop of an aircraft that was trying to turn because its geometry insisted on turning. The alignment was checked with a ruler, and with the eye and with the builder's understanding of what square looked like in 3 dimensions. And it was correct or it was not. And the model would tell you which. The discipline of the build had a social dimension that the solitary workshop experience did not reveal. When you brought a newly completed model to the field, the local park where the free flight community met on Sunday mornings, or the schoolyard where the control line pilots drew their circles on the asphalt, the other builders looked at it, and not judgmentally, not in the competitive way that strangers examine each other's property, but with the specific attention of people who understood what they were looking at and who had opinions worth expressing. They could see from the covering whether the dope had been applied correctly. They could see from the wingtip's geometry whether the tip had been built over the plan or freehand. They could look at the fin alignment and tell you, from experience with the same design or with designs of the same type, whether the aircraft was likely to fly straight or to pull in one direction. This was the informal education that the plan-building culture organized around the flying field as much as around the building board. You learned at the building board from the plan and from your own mistakes. You learned at the field from the people who had been doing this longer than you had and who were generous with what they knew. Because the generosity was the culture, you had received it from someone else, and you passed it on, and the chain of transmission was how the knowledge propagated through the community. And an older builder who watched a younger builder launch a model that immediately rolled into the ground and walked over to look at the aircraft and explain what had happened and what needed to be corrected was performing the fundamental act of the hobby community, keeping the knowledge alive by sharing it with someone who needed it. The engine installation for the powered models in the Jetco line was the final mechanical commitment before the maiden flight. The glow engine had to be mounted on the firewall with the thrust line aligned correctly, the down thrust and right thrust that most glow engine designs built into the motor mount, which corrected for the torque and propeller effects that would otherwise make the aircraft roll and yaw under power. The engine bolts had to be tightened with the specific firmness that prevented the engine from moving under the vibration of operation without distorting the firewall. The fuel tank had to be positioned at the correct height relative to the needle valve, because the fuel delivery was gravity assisted, and the relationship between the tank and the carburetor affected the mixture at different flight attitudes. Then the field. The maiden flight of a Jetco model, or of any balsa model, built from plans from any manufacturer, was the examination that the weeks of building had been preparing for. You had done the work. The ribs were in their correct positions, and the wing had been checked for warp and found flat. The tail was aligned. The engine was mounted and running correctly. The needle valve set for the conditions of the day. You held the model, checked the balance point against the plan specification one final time, and launched. The model either flew or it told you what you had gotten wrong. There was no intermediate condition. A correctly trimmed model climbed in the gradual, efficient arc that the designer had intended. Incorrectly trimmed model expressed the nature of its errors immediately and completely, in the language of an aircraft that wanted to go somewhere other than where you intended. Both outcomes were educational. The second kind was more educational because it required you to diagnose the error and correct it and fly again. And the diagnosis required an understanding of what each kind of misbehavior indicated about which trimming adjustment needed to be made. The Jetco catalog, at its peak, covered a range of the model aviation world that reflected the company's roots and its evolution. The thermic gliders that Frank Zaic had designed for the JASCO era continued in the Jetco line, designs that were reproduced in kit form alongside the newer Ehling designs, maintaining the connection to the aerodynamic tradition that the Zaic family had established. Then, the Nordic was a high point, a tow-line glider whose design was genuinely competitive at a time when tow-line gliding was a serious AMA-sanctioned event with a developed community of dedicated participants. The Phoenix series covered the powered performance classes, the RC transition models, single channel in the early period, expanding to multi-channel as the technology developed, connected Jetco to the growing community of pilots who were discovering that radio control made model aviation a genuinely pilot-centered activity rather than a build-and-watch-it-go experience. The Piper Super Cruiser at 40-inch wingspan, the Eaglet rubber-powered design, the Talon glider with its 80-inch span for the Nordic A2 class. Each of these was a physical argument for the same proposition that every Jetco kit made, that building a model aircraft from a set of plans, from thin balsa sheets and tissue and dope, and whatever engine or rubber motor was appropriate to the design was an experience worth having. Not because the finished aircraft was superior to a commercially assembled aircraft in any operational sense. It was not always superior. The factory-built aircraft of the ARF era that came later flew correctly from the first flight without the trimming and adjustment that the plan-built model sometimes required. The plan-built model was superior in a different sense entirely, in what it gave to the person who built it. What Jetco gave was the experience of making, not the experience of assembling. Assembling is connecting pre-formed parts in the sequence that the manufacturer specifies, and it produces competence in assembly. Making is different. Making is the encounter with raw material and the development of judgment about how to work it. The accumulation of skill through the practice of repeatedly doing a thing until the thing is done correctly, without conscious effort. The modeler, who had built a dozen Jetco kits, had made something of themselves through the making of the aircraft, had developed a patience and a spatial reasoning, and a specific kind of manual competence that transferred to every other physical task they encountered. The forces that eventually eroded the market for kit building arrived from several directions simultaneously, and none of them was simple or easily characterized as a mistake or a failure. The almost ready-to-fly category, which began appearing in the late 1980s and accelerated through the 1990s, was a response to a real demand, a growing population of people who wanted to fly model aircraft and not build them, who valued the flying experience and found the building process an obstacle rather than a pleasure. The ARF served this population honestly and well. It was not a lesser thing that pretended to be the same thing. It was a different thing with different values and different outcomes. And the attention economy that developed alongside the digital revolution changed the conditions under which the building culture could sustain itself. The kit building hobby asked for a sustained investment of attention over weeks, attention that returned its investment slowly, in increments, with no dramatic confirmation of progress at the end of each session, except the barely visible accumulation of one more wing rib in its place, one more stringer glued and drying, one more small step towards something that would not be recognizable as what it was going to become until most of the work was already done. This is a specific kind of engagement that the digital world, which returned its investments immediately and visibly, provided less and less support for. The child who had grown up with the immediate feedback loop of video games and smartphones did not lack intelligence or patience in any fundamental sense. They had learned a different tempo. The slow tempo of the building board was not part of their experience, and acquiring it would have required the kind of deliberate practice that the culture around them was not organized to encourage. The foam revolution that followed was similarly responsive to real preferences. Expanded polystyrene and expanded polypropylene could be manufactured at lower cost and with less labor than balsa construction, and they offered crash survivability that balsa could not match, and a foam model that flew into the ground at moderate speed might survive the impact. A balsa model under the same conditions was typically a collection of splinters. For the pilot who was still developing skill and who expected to fly into the ground occasionally in the process of developing it, the foam model was the rational choice. The offshore manufacturing pressure changed the economics of American domestic kit production in ways that were not easily reversed. The cost of die-cutting balsa in New Jersey or New York, of printing plans and packaging kits, and distributing them through a network of hobby shops was substantially higher than the cost of comparable operations in China or Taiwan. And by the mid-1980s, the differential was large enough to make domestic kit manufacturing commercially precarious. The hobby shops themselves were contracting. The large mail-order retailers were changing the economics of distribution, and the internet completed the disruption in the 1990s. The independent hobby shop, which had been the social and commercial infrastructure of the kit-building culture, became increasingly rare. Jetco did not survive these forces as an ongoing manufacturing operation. The company that had begun as JASCO in a New York supply operation in 1933, that had transitioned through Frank Zaic's aerodynamic genius to Frank Ehling's productive design partnership with Frank Zaic, that had navigated the transition from rubber power to glow power to early radio control, eventually ceased production in the kits, disappeared from the hobby shop shelves. The plans were archived, some of them preserved by the Academy of Model Aeronautics, others by collectors and enthusiasts who understood what they were preserving. The designs themselves survived in various forms, reproduced by organizations like the Paul and Ralph Bradley Operation, which produced print-on-demand versions of Jetco and JASCO kits for builders who wanted the experience of the original. What is lost when blueprints disappear? The question is not rhetorical, and the answer is not simply that beautiful balsa models are no longer produced. Beautiful balsa models are still produced by a small and dedicated community of builders who have sought out the plans and the materials and the skills required to build them. What is lost when the plan-based kit culture disappears is something different. The transmission mechanism. The kit was not just a product. It was a curriculum, an organized, sequenced introduction to a body of knowledge and practice that moved the builder from beginner to competent through the specific experience of building successive kits of increasing complexity. The eaglet rubber-powered model as the first kit, teaching the basics of tissue and dope and rubber motor and rudder trim. The Phoenix as the intermediate kit, adding the engine installation and the needle valve, and the control line flying that demanded a different relationship between pilot and aircraft. And the Nordic as the advanced kit, requiring precision alignment and careful weight management, and the understanding of slow-speed aerodynamics that made a competitive tow-line glider perform. This progression was not a school curriculum. It had no teachers, no grades, no formal acknowledgement. It happened at kitchen tables and workbenches and in the basements of houses where the smell of dope was so familiar that the family had stopped noticing it. And it happened because the kits were organized in a way that made the progression visible and accessible. And because the hobby shop counterperson could look at what a builder had completed and recommend what they should build next, when the progression disappeared, when the ARF removed the building, and the foam removed the material knowledge, and the online retail removed the counterperson, the informal curriculum that the kit culture had organized disappeared with it. If you built kits, if you have a specific memory of a Jetco design that you built and what it was like to fly it, or to fail to fly it, or to rebuild the part that failed and try again, leave that memory in the comments. The history of this craft is not preserved in corporate archives or manufacturing records. It is preserved in the specific felt accounts of the people who practiced it. And the only way those accounts survive is if the people who carry them choose to share them. This channel exists partly for that reason. And the invitation to comment is not a social media formality. It is a genuine request for testimony. The model is on the shelf, not a reproduction, not a display piece purchased at a hobby shop's going out of business sale. And a model that was built from the plans, from the die-cut sheets, from the tissue and the dope and the patience required to apply them correctly. And it has been there for years, possibly for decades, in the specific stillness that a built thing has when it is finished and at rest. The tissue has settled into the ribs in the way that tissue settles over time, slightly tighter in some places, slightly softer in others, the dope having done its long work of holding the covering against the structure through summers and winters and the small expansions and contractions that temperature change imposes on a material that was once a living tree. The colors, if it was painted, have faded to something slightly more muted than their original intensity. The way that paint from that era ages, not badly, but honestly in a way that marks the time without destroying the appearance. The model carries what was put into it. Not only the materials, the specific grade of balsa that the Zaic family had understood needed to be good wood, the tissue applied with the patience that the tissue required, the dope that smelled of chemistry and transformation, but the hours, the evenings at the building board, and the specific attention that each rib required, and the accumulating confidence as one rib became 10, became 50. The wing taking shape over the plan and becoming recognizable as what it was going to be. The decisions, the mistakes, and the corrections. The knowledge gradually acquired through the doing of the thing that lived afterward in the hands of the person who had done it. Jetco Models gave people the opportunity to have that experience. Not the experience of owning a model, which requires only money and patience for a delivery. The experience of making a model, which requires time and attention and the specific willingness to return to something difficult evening after evening, because the thing that is being made is worth the difficulty of making it. The shelf is quiet. The model is still. The aircraft that existed only in the rolled plan, the aircraft that the drawing had described and the builder had brought into the world one rib at a time, has been in the world now for as long as the builder has been patient enough to keep it there. Frank Zaic understood this. So did Christine. So did Frank Ehling, who designed for them. And so did every person who ever opened a Jetco box and unrolled the plans and understood, in that first moment of looking at the drawing, that this was going to take weeks, and that the weeks were going to be worth it. And the plan is still on the building board. The balsa is waiting.